Good afternoon, everyone, and welcome to edTrends. I'm Dr. Rivera Wilson, and I'm here to share with you reimagining science labs instruction when teaching in hybrid and virtual models with the New York State Master Teachers. If you're interested in receiving CTLE for today's participation, please visit remoteed.org. In January, we will be launching our book study on grading for equity, and this is also with the New York State Master Teachers. If you're interested in registering for participation, please visit remoteed.org for more information. And now to talk about the New York State Master Teacher Program, I will introduce you to Dr. Rory Glass with the School of Education at the University of Albany.
Thanks, Jerry. Good afternoon, everybody. My name is Rory. I appreciate you all joining us today. Master Teacher Program has been teamed up with Atlas and Remote Ed now since back in the beginning of summer. And this is all part of an ongoing series that we've been doing along with them since then. Today, I'm grateful that I have two of my master teachers from the region here, Stephanie Loomis and Annette Subirra, and they're going to be talking about their lab practices in these crazy times. So without any further ado, ladies, it is yours.
Okay. Thank you. My name is Stephanie Loomis. This is my third year in the Master Teacher Program, and I'm a physics and chemistry teacher at Catskill High School, which is about 30 miles south of Albany. We were remote for September and October. We went hybrid at the end of October, beginning of November. So I've been both a remote and a hybrid teacher this school year. And we are synchronous. So even though my students may be in class and at home at the same time, they are required to come to class every day at the right time that we have lab and class. So I'm running my labs and my classes with all of my students going on at the same time.
Good evening. I'm Annette Subirra. I'm also in my third year of the Master Teacher Program. I teach at Gilderland High School, and I teach a blend of advanced chemistry with the Syracuse Project Advance. I teach the honors chemistry labs. I also teach a Regents class. We have been hybrid. I have been in person since September. We work 5 days a week and also synchronous.
What have I done to change my teaching this year? I flipped my classroom. I said semi-flip because there are days I still do notes in class, but for the most part, my students are doing their notes at home. I'm doing open note assessments. So their quizzes, their tests and things like that are all open note. I do still have my students handwrite their work though and submit PDFs. I've been able to get all of them to figure out how to scan with their cell phones or with their computers to make a PDF and submit that into Classroom. We found, especially in the spring, I found it very difficult for my kids in chemistry to try to do math and to try to show formulas and things like that by trying to type it in the computer. So we do have them writing it on paper still and then submitting those PDFs. I have done a lot more digital labs and labs that we can complete at home, as well as labs in class. I try to make sure that no matter if they're in class or at home, they're able to participate in whatever labs we're doing. And so we're trying to find different ways to make sure they're all engaged. And also with the kids at home, I'm trying to get them to get their families engaged. So I have students having their parents and their siblings helping them with their lab collection.
I, on the other side, have completely slowed down my pace. I have started, this is the first year where there's open note assessments so that the students are more vested in having their notes handy and they can be helpful at the end. We use Kami and all our students are one-on-one. They all have their Chromebooks. And so I'm able to either get typed information or handwritten information. I stopped a lot of the photography because I'd have a giant photo of the keyboard and a very tiny letter whereby the students were sending me half a page. And so the photography wasn't going that well. So I heavily rely on the Kami tool. I have fewer hands-on labs, about a third the usual. So if I used to do 24 labs, hands-on labs a year, I'm down to 8. But on that 1/3 on those hands-on labs, those can all be done at home. So we all do them together instead of having someone on campus doing the lab and the person at home taking data. And so we adjust accordingly. And I depend a lot on those Google Forms to pull the need of the materials and equipment needed for the upcoming lab. So that's why I slowed them down to a third, because then I take about 3 weeks in between each one. And oh yeah, all my hands-on labs can be done at home. We do household products.
So I use a bunch of different resources. We're a Google school. So being that we're a Google school, I do spend a lot of time using Google Docs and Sheets and slides and forms. We also, on my iPad, I have the ability when I'm home teaching, or when they send us home to teach, I can teach from my iPad. I use Explain Everything for the iPad. We do a lot of data collection, especially through physics, using YouTube and Physics Avery. And also I've been working with other science teachers to kind of share each other's resources, which definitely has helped, because otherwise I feel like a lot of times I'm recreating these wheels that, I've been teaching for 22 years, and many days I feel like a brand new teacher again, because I'm trying to figure out how to make a new lab or rewrite something or do something. So I'm really grateful that I have a group of teachers that I am able to reach out to and say, hey, does anybody have any ideas for this? So definitely using that. And I've learned a lot about using Google Slides, especially in docs and forms, as Annette was saying, to collect information from the students.
I too use the Google Suite, Classroom, the Meet, the Calendar, the Kami, not so much of the Jamboard. The beginning of the year, we all made ourselves we have a group of 7 chemistry teachers. So as far as the content material, we made each other members of each other's classroom co-teachers. So all our information is in a hub and you can go back and forth. So even if the teacher is not able to be with you and explain what was done, you can go into the classroom, read the instructions, and then use that material, and then just share your feedback with that teacher. And that collaboration piece is working really, really well. The school does have a license for Castle Learning, which has populated the past Regents exams. And so it's about the same questions that would have been on an exam gen. Unfortunately, the most recent on Castle Learning is a 2011 exam. It's not that up to date, but that is an option in which the students can also take an assessment. I did poll my students and I asked them between Kami and Castle Learning, and hands down they chose Kami. So I rely a lot on that one because it's more like them writing on their own piece of paper. I also use College Board for my advanced placement because they have daily videos. And I also do not mandate them, but it's a go-to extra resource for students. I use Skype a Scientist, where you can get so much information because there's so many experts out in a field. And so I can use that either by using a snippet of a speech that was given, or most of the scientists are very happy to dedicate anywhere between 20 to 40 minutes. So I meet with a scientist and we figure out what types of questions that I can have the students work on when they are done. The Science Coach program through ACS is also really, really helpful. And that's where we do our long-term research projects. And especially with the instrumentation and analysis, we're able to work with, currently my coach is from RPI and he's really, really helpful. Whiteboard is a new tool that I've just fallen in love with and completely love, and it's just a nice way to be able to see all of the submissions on one platform, socially distanced, whereby students can either work on a worksheet that you have pushed to them, or they can cut and paste what they have just submitted if you wanted to do a ticket, and they'll leave that with you. Or you can currently be able to see students working on assigned issues, and then you can sort of communicate with them on one-on-one, letting them know, maybe you used the wrong symbol or good job. It's just an instant feedback, and it's one that's really positive. Edpuzzle, all my quizzes, I'm using Edpuzzle. There's quite a wealth of quizzes and videos that colleagues all around the US have placed up there. So that is something that's become a really useful piece for me. I've made my own Edpuzzles. I use somebody else's Edpuzzles, but it's endless. So that is what I use for the quizzes, and the students do them on their own time. And there's that wonderful tool that doesn't allow them, where you click on it and it doesn't allow them to skip forward. So even though they will do that, the messages that I get back will let me know, so I can have a conversation with the student who says, I still don't get it, whereby I can say, well, you took something that takes a half hour and you did it in 2 minutes. Maybe you need to slow your pace down. So it's a nice way to let them know and send them back. I have to answer something, I think. Okay, go ahead. Next slide.
So a bunch of labs. We thought we would talk to you guys about a couple of different labs that we do in our classes, and kind of give you some ideas of how we've been able to get the students both in person and at home to work on them. So one of the labs I do is an introduction to green chemistry and lab procedures. And so at the beginning of the year, I give the students this really convoluted lab procedure, and I have them read through it. And I do a demonstration following the entire procedure, and it has some, crazy things in there, like, telling them to do jumping jacks and throw stuff in the air. And so I have them go and they rewrite the procedure, and we talk about why it's important to make. In the procedure lab, I have them rewrite the procedure. And then from there, I have the students go home and make the lemonade with their families, and they have to follow the instructions and the procedure that they wrote. So trying to get them to do the lab procedure at home. And again, it's using simple things like sugar and lemons and things like that. Another lab we do is our molecular moles lab, where they're making Play-Doh using household products. And then they use the Play-Doh to make molecules. And we talk about molecular structure and polar and non-polar. And then from there, we lead them to drawing Lewis dot structures and talking about bonding. And so, but then making the Play-Doh themselves from scratch and then using it in the lab. I do a chemistry of cooking lab where we talk about physical and chemical changes. So the students have to pick a recipe, and they have to write that recipe like they're writing a lab procedure. And then they have to make the recipe, and they have to collect all their supplies. So they take pictures of all their materials, and we talk about materials lists, and at first they're listing just the ingredients that are on the recipe. And then we talk about, okay, well, how is the stuff just on the counter? Do you put it in a bowl? Do you need a spoon? Do you need, what do you need heat? And we talk about all those different things. Another lab I do that I didn't put on there is in my physics labs. We did a distance versus displacement lab. In that distance versus displacement lab, I had the students measure from their bedrooms to their kitchen to the bathroom, and they had to draw scale diagrams. And then on graph paper, they drew scale diagrams. And then from the scale diagram, they had to figure out the distance and the displacement from room to room. And so we talked about scale diagrams, but we also were able to look at distance and displacement. Some other physics labs we're doing, as I said, are virtual online. My students just finished a lab on equilibrium and net forces. So they were collecting information and then screenshotting using the programs online. And the last one I have on there is my chemistry scavenger hunt, which I'll do in the spring. It has a bunch of different applications, both physical and chemical properties, and the students have to find things in their house and explain them and put pictures and show how those pieces go together from things that they've learned throughout the year.
All right, so you can see that all my labs, the titles is material that's found at home. So the first lab that I did this year was called the soil lab, and it was a soil analysis lab. And I was able to do this lab for my Regents classes and also for my advanced placement classes. And the outcome responsibilities of the analysis were at different levels. So my Regents chemistry is their first year of chemistry. And so in the past, they've been able to do questions, which one of the following is a heterogeneous mixture, and they're supposed to know that it's soil. So I just thought that this was such a rich resource that we could use. And the soil lab addresses matter, it addresses mixtures, it addresses mixture separation, particle size, and then geographic. And so this is in their homes. And so we were able to do the soil lab. We had, I pulled the students. So on the very first day of classes, I gave my students 2 pieces of homework. The first homework was for their parents, and I asked them to ask their parents to write me an email singing their praises, because teenagers, when you ask them a question, how was school today? What did you guys do? Not much. And so I just wanted to know who I was dealing with this year, especially because it's just been a difficult year coming from the spring. And the second one's to get a sandwich baggie full of soil. And it had to be dug at least 4 inches deep. And so it was really interesting to have that conversations, my students thinking I'm a crazy woman who's looking for dirt, students telling me how they were seen with shovels going in the backyard and people were suspicious. However, what we were able to do is that we were able to do soil density lab. And so I had a third of my students in school because they were divided into 2 groups. And the students in school did a microscopic examination. I encouraged them to take a photograph of it and share it with the colleagues who were put in their team. The students in school could put the photograph that they took of the soil with the particle sizes on a microscopic level. The students at home had to draw. They had to sketch the photograph that had been given to them, because I wanted them to be sensitive to the fact that these were different particle sizes. The second part of lab, some of the students in school chose to do the mass, percent by mass, whereby they were using the sifters. And some of the students in school chose to do just the density settling of adding detergent and water to the graduated cylinder. All in all, we were all able to come up with our calculations on what the percent soil was made up. I introduced the soil triangle because we use that in the forensics class too. And the students were able to figure out what type of soil that they had. The purpose in this is that not only are they learning chemistry, but as we go towards the end of the year, we plan on mapping the soils of the region where I teach, whereby the students will be able to see where they live and what type of soil they have there. So whether I have a student in my Regents class or a student in my AP chemistry class, if they live in the same region, their soil composition should be around the same. And then that will lead to other conversations. The second lab that I did was, which is the best antacid? And this is for mostly consumer science. I did not specify which antacid that they had to take, but this is a lab that can be stretched out into gas laws, properties of gases, acid-base reactions, balancing reactions, neutralization, percent yield. It's just a rich lab that you can work with. The students who were in school were able to run the reaction using the loss of mass rather than a gravimetric balance. The students at home were able to use how much gas was inflated in a bag and be able to find out the volume of the gas. But all in all, we came up with the same results. And by knowing which is the best antacid, in their hypothesis, the students stated, my antacid, the job of the antacid is to reduce the amount of acidity in your stomach by eliminating some of the carbon dioxide when this reaction takes place. I provided the chemical reaction. From the chemical reaction, they were able to see that the main thing coming off was CO2, and having studied matter, they did know that that's a gas. So by filling a Ziploc baggie to the same capacity as the inflated bag, we were able to figure out the volume, and we were using our household cup measures, the baking cups, and being able to measure that. So that's another lab that I will revisit, but now the students know what the reaction is. but you can go back and use this if you go into acid-base reaction. Once you get to balancing, if it's a particle diagram. So that's one that you can revisit. So the last one that I wanted to share with you was that when we were studying atomic structure and then we got into the history of the development of the atom and being able to explain to students why the Bohr model is no longer our go-to model, but we continue to use it. In other words, saying that that is a good for showing that they are energy levels, but that's not what they look like. We were able to work with the emission of light, energy changes, the wavelengths of light, pigments. So we use the fall leaves. So I gave them what I call a long-term project. And in the fall, beginning at around October 1st, they were to grab a leaf from the outside, and I wanted a green one. And then they had to get 2 leaves of the same tree. What we ended up with was a series of the pigments of the leaves as they change in the fall. We went all the way from greens and we ended up in reds. And we were able to calculate the amount of energy the leaves have at that time. We were able to use the pigment that's available in there for the advanced placement students. They're able to work out what the calculation for the energy is. We use the color wheel, whereby the kids, we always say, oh yeah, the leaves, they change color and the color disappears. But we were able to work into absorption, and that the color you see, something's being absorbed and something's being reflected. So it ended up being a really pretty fantastic lab, but it was also a teaching moment.
Annette, there was a question in the
Yeah,
chat from Kelly.
Yeah.
Okay.
Yeah, I see it. She said,
Okay.
how do you do these labs with current social distancing protocols? So what I do, if I'm doing a lab in the classroom, I split my lab groups up. We have hybrid A and hybrid B, and then our virtual kids. So I take every group and I make an A kid, a B kid, and a virtual kid in a group. So the kids that are in the room are working by themselves with 2 other students that are on a Google Meet. So I use breakout rooms quite a bit in a Google Meet. So they are still separated, social distancing protocols. Every kid's at its own lab bench. There's nobody sharing lab benches. For materials, I'm lucky enough that my lab classes, I have a break before my next lab class. So yes, I do clean and sterilize all of the equipment. Our district has bought us spray bottles to sanitize and clean everything. But I do have enough materials to get me through a day of lab since we don't have as many students in the room. And then I can clean and be ready for the next day. My students do not share materials. I have separate setups for every kid. Every kid in my room has their own lab drawer where they have their own like standard lab equipment. And then if anything else that has to be cleaned and redone, I do during the day. The kids that are at home, I don't modify the labs at home. They're doing the exact same labs. Sometimes they are collecting data from a student that's in the room, but some of my labs, both students at home and in person can do. Because we do a lot of kitchen chemistry in a sense. It's household products. It's things that they would have at home. I've actually changed a lot of my labs in class to be stuff that they can do at home. So, we're using baking soda and sugar and flour and water and cleaning supplies or things like that that are around. And I don't know if you have anything else you want to add.
So yeah, for social distance, luckily I have not had more than 7 students in the room at any given time. My room is large enough, and for the material, but my classes are back to back. So we have 84 minutes, 3 times out of the 4. Gilderland goes to school Monday to Friday. We don't have an off day. So my solution to that, in other words, if I do not have enough glassware to cover me first and second, my students clean up. But what I did is that I had the school purchase gloves for me. So everything that is going to be touched is handled by gloves. And so my students use the gloves. They still wash out the glassware as they're leaving and they leave their station. I'm able to clean the surface. But as far as the glasses and trying to spray them with the sanitizer, the QT3 that we were given, I use gloves. And so that helps me. So they wash them with soap and water, and they leave them at the tray. But block 1 is set up on the outer part of the lab. Block 2 is set up on the inner part of the lab. And then block 3 is set up on the outer part of the lab. So there's a skip, and just like Steph, each of the students have their own drawers. We provided goggles for each of the kids. Some students opted to buy their own. We provided the aprons. We wrote their names on it. But I keep extra of about 20 because on any given day, a student might say, I forgot it. And then I'll say, well, this is yours. You have to keep it again. So some kids have notoriously got about 3 aprons because they keep forgetting each time. And so the distancing has worked out okay, only because we did not have as many students as we would have had in the spring in our classes.
So we have another question. It says, are all your students on the Google Meet together? For me, yes, I am synchronous. So no matter if it's an A day, a B day, a remote day, no matter what it is, like right now, we got sent home again. So we're home teaching. All my kids, no matter what day it is, they're all on the Meet. So yeah, I have it so that all of my kids, no matter what, are all involved in the class.
So when you have somebody that's like, so when you're actually in class and you're not remote, and you have like, say 7 in your room, 7 at home, whatever, are your 7 in the class logged on to the Google Meet as well?
Yes, they will be if I'm going to put them in breakout rooms. So yes,
Okay.
we're in lab. Yep, I have everybody log in. And once you put them in the breakout room, the interference and all that goes away.
Okay, that's what I was going to ask you. So
yeah, so you don't have it. So when they first log in, we figure the system out. When they first log in, they turn off their volume and they're muted. But as soon as they're in the breakout room, they can turn the volume right up, unmute, and there's no interference between each group.
Okay, and then are you allowed to pick? I've never actually done breakout rooms yet, but are you allowed to pick like who's in what group so you can make sure that there's not?
Yes, I have to do that so that the next lab class, when they come in, I can make sure the same kids are in the same group. So if they're finishing up a lab. So yeah, you can pick.
Okay, so you said, so you have groups of 3. So your A group is in person, your remote group is like your B group. And then did you say you had another?
I have 3. So I would usually put a person from the group so our kids come in Monday, Tuesday, Thursday, Friday. So I'll a Monday, Tuesday kid with a Thursday, Friday kid, and with a kid that's virtually remote all the time and put them together so that I always have at least one person in the room when we have class.
Okay, so your kids, so if you have a Thursday, Friday kid, they're still logged on remotely with your Wednesday.
Yeah.
Okay. I'm just trying to see your difference in structure versus mine so I can see how that works. I do like how you have paired them with the remote person so they can see what they're like, what the lab is doing. It's sort of like they're doing the lab with them. That's a really neat idea that I actually haven't thought of.
Yeah. So so that's made a big difference. My kids at home actually tell me that they feel more included so that they can, they feel like they're part of that lab group because they're actually there. So it's nice.
Steph, can I just say one thing? Because I'm fully virtual. It depends when it comes to breakout rooms. I love them as well, use them a lot, but you have to figure out each platform is different. So whether you're using your Teams, Zoom, Google Meets,
right,
whatever the school uses, there's different abilities to select and
so we're a Google school, so we're using Google Meet. So yeah, it's definitely different if you're using something else.
On my situation, I have the same division whereby we have 100% remote, and then we have group 1 and group 2. And with Google Meet, it depends on what we're doing. If we're doing a lab, so for example, if the students have to provide data to the kids at home, then I would team them up the same way Steph has. But there are other activities but we're not collecting data, but it involves collaboration. And I have had students say, I would rather speak to so-and-so who's right here in the room. So I will put the students who are not in the classroom in different meets. And the ones who are in my room do not have to log into Meet because I can hear them speaking in there. So I vary it up depending on what the activity is. Okay, next slide.
For students working remotely with limited resources, such as those students in low-income families or who are experiencing homelessness, what supports are you provided? And access to hands-on labs. Okay, Annette, you go first, and then I'll go.
All right, so for Guilderland, we rely a lot on the bus service, whereby we can actually, in my situation, what I did at the beginning of the year is that when I did the All About You Google form, we were able to, I put in questions whereby if you have someone who can come to school and get you material, would you be able to have that person pick up the material for you from school? If so, who is it? So we set up that standard there. So there are students who are not full remote who report to school. And so they are my ambassadors and they'll be able to take material. It's always given in advance. And then for those students who come to school and do not have those resources, I also have that available for them. So for example, here's an example of a simple activity. We did the percent sugar in gum, and something as simple as gum, you might think, oh, you know, everybody can get gum. But what I do is that 2 weeks before we do that lab, I said, guys, I have this gum. We're going to be doing this lab. How many of you want me to provide them with a gum? And most of them will say, yes, you know, provide me with that gum. I'm going to be at home. I'm going to be different. I'm going to be remote. So if a student does not have someone or a buddy system or a parent cannot come and get it, then I use the bus service, whereby we found out, especially from that first Google form that I did, what is their bus. And if I know what their bus is or their bus route is, then the material goes home on the bus. And I just communicate with the student that, you know, the material is going to be on the bus on Monday, you have to meet it. So because the bus is still going in the same direction, the bus drivers are very helpful in getting that material to them.
So for me, it's a little different. But one of the things we do have is all of our students have Chromebooks and internet access thanks to our administrators at our school. So that makes a huge difference with at least being able to be with them and see them at all times, which is great. That does make a big difference. The other thing with supplies, my students are actually coming to the building and getting stuff when they need it. So if they need any supplies, I always tell them to let me know. Even if it's a lab or a note packet, I have a couple of kids that are like, I don't want to type this on the computer. Can I handwrite it? Can I come get a hard copy? We actually have a system going in our office where they can stop by, and that says have someone come and get it for them. And pick it up and bring it home. So we've been doing that. I've sent a bunch of things home with kids back and forth as we need to. We're trying to finish up, trying to get some more morale going on the building. So we started a chemistry this year in our building, in my room. So we have all these ring stands and stuff, and we had the kids make ornaments that are, or decorations that are having to do with the elements in the periodic table, or having to do with their physics unit for force, because we got the physics kids involved too. And we had living environment kids building DNA and RNA trains and things like that. And so I had told the kids, just drop them off. So they were coming into the office and we were hanging them all up on the thing. So we're doing this both ways. They're dropping stuff off for me. I'm sending things home for them. I think we're ready for the next slide. There we go. So in that, we were told we can share our stuff, our screen if we want to, because this is the old slide that we originally had. So from this slide, you can see I have some pictures on here of some of the things that the students have done. So the first set of pictures there is their Play-Doh lab. So you can see from there that they made their molecules and then they had to fill in this chart about their structures. So you can kind of see that there. And then at the bottom left is an example from our scavenger hunt of something they had to do. They had to figure out what a heterogeneous mixture was and then find something in their house that it was a heterogeneous mixture and post a picture. And then at the bottom right corner is a picture of our Beanium lab. And this is a lab where the kids in class collected the data in terms of the masses. And then all of the students had to figure out the average atomic mass of Beanium using the information that was collected. So this is one of the labs where the kids in class were sharing information with the kids at home so that they can make sure that everybody had the data. And then we analyze that and kind of look at the numbers. So again, these are just different pieces of what the students have done over the spring and then in this fall.
Can I click on it? Jerry, maybe the last one, the bottom one or something? Any one of them.
The link's working. Annette, she said we could share the slides if you want. So if you have that, our actual like Google slides open, you probably can share it that way if you want.
All right. So I think Jerry would have to give me permission to.
Oh,
all right. So, okay. So here is an example of the leaves. Do I have control? I'm confused. Sorry. Can this be, Jerry, is this you controlling?
Yes, Annette, why don't you try and take over the screen because Jerry's presenting right now.
I tried to, but it says it's been disabled.
No, you have co-host privileges.
Okay.
This is awesome, by the way, you guys. Thanks for sharing.
Right.
You're welcome. Thank you.
So slide down. All right. So the fall leaves, I got to present. To show the fall leaves outcome. So each of the students was given a, it takes a while to load, was given a pigment to work with. And so this one here just happens to be the carotenoids, the beta carotenoids, and they were able to tie the color that they have. They were able to tie the color that they have to the specific wavelength. They use the color wheel to see that when you see the leaves are red, it's because the green has been absorbed, which was the original chlorophyll. Some foods have the same pigments in them. So I really like this. And then here's the chemistry of it, being able to come up with a chemical formula, the structural formula. Now, this doesn't really mean a lot to the students right now, but they can see that it's a long molecule, which is something we'll revisit when we start talking about polymers. But they do know the energy, they do know the amount of energy and the wavelengths or the specific frequencies. So that's one of the things that they did. So by having their leaves, and then this was a follow-up, and I randomized all the pigments that I could think of, and I assigned them. Some kids had chlorophyll A, some had chlorophyll B, and some had xanthanons, and so it was all different. But I wanted them to see that just because we see the pretty fall foliage, that it's all chemistry happening around them. And then the other one that I wanted to share with you was, oh, you saw the leaf picture. So here's a different student. That first one was a different student. And he is a student who had gathered their pictures. On the next page that's not shown here, they put a date. They placed a date on when they picked up each of the pictures. So going all the way from the greens and ending up in the reds. And for the soil lab, so for the soil lab, this year, I'm making most of my lab reports be slides in Google Slides, only because it's better for me to navigate. But you can see that the students answer, they have an investigation question, they have a purpose, they have a background, they set up their hypothesis. I always train them to say, if this and then that. This is the material and equipment list. And here is a microscope picture. So here is a microscopic picture of it. And this person was at school. And so they would say, this is the photography taken by this person. The person at home has to sketch this. With the outcome, they made observations and they were able, if you were at home and if you're in school, I wanted to see the picture of what it is that you were doing. So you can see a student has done their setup, their water, their detergent, the Ziploc baggie, and they used a water bottle because I asked them to get a cylindrical substance that we could use to fill with water. And then here are the measurements and calculations. And in the end, you can see that with the soil triangle tied in there, but then they're able to classify their soil. Now, some of the students, if they were not in advanced placement, I stopped here. But I wanted them to kind of talk about the daily application and where you see this And essentially, I wanted them to know that, soil is an amazing filter that exists naturally, and that, when you have wells, that's where the comes from. And you can see here a real world application of this phenomenon. As far as the percent Alka-Seltzer, this is the one where the students in school, so the background I provided, the investigation design was their own. And so they had to do some reading up to see, but here's somebody at home sending me their setup, whereby they had the measuring spoons, they had to grind up the tablet that they used. The students had different ones, and it was really nice to see. In the end, we shared our results, and the students were able to compete and say, this is better. And I'm afraid to tell you guys which is the best antacid, because they won't give me royalties for that. But I like that they're showing me what they're doing at home. I like that they're sharing their calculations. And as always, I like that they have to tie in the green chemistry principles and talk about which ones that they applied. And I think that's a stop share, unless you want to see any one of these. I think I did all of them. Here you go. We're back on, right?
Yes, you're good.
Okay.
We can see your lovely face.
I think Jerry has to take over. Or Rory. Should we monitor the chat? I can answer more questions.
I don't see any more questions yet, but if anybody has any other questions or comments or ideas, please.
Yeah, place them in here. I do use the PhET labs. Those are helpful. And also AACT has some wonderful, interactive labs. And I think PhET has a lot of the physics, but they've, it's a big improvement from where we were in the spring. So when you keep looking at that, and there are many, many hubs that are sort of loading their labs there on the same sites.
So yeah, I've been using even YouTube videos. There's a lot of people out there that are posting data collection on YouTube that I've been using. I've used a lot of PhET simulations for a physics lab, especially. We use definitely a lot of those for data collection for physics.
Okay.
So PhET is an online program where you can, somebody just asked what PhET was. It's an online program where students can virtually manipulate lab equipment. So chemistry, I know I do atomic structure on there. So the students, it's PhET, yep. Students can go on there, and we do a lot of atomic structure on there. So the students can, build atoms and ions and things like that. Oh, thanks, Regina.
Thank you. Yeah.
So there's the link. So they have them for all subjects, and I say they've improved a lot since the spring too. There's a lot more available that you can use, which is really nice.
We just completed doing the percent hydrate in a salt, and that's also it's a PhET. They actually, you can see them in the crucible burning up some copper sulfate pentahydrate. They record the mass for you, they give it to you, and then your students can do the analysis. So they are really, really improving on that. We recently discovered one on chemical based on the properties, and they have 2 ionic substances, 2 molecular substances. They have a metallic substance, and then they also have a network solid, and they tell you to dissolve them in water and then test for conductivity if they dissolve. And then they ask to run a timer and stop the timer once the substance is melted on a hot plate. So you can use that. It's not the best, but since we are remote, it's a nice visual, and students can go back and forth and work at their own pace.
Oh, you just mentioned the hydrates too. So I hydrate lab with my students, but we do the percent composition in microwave popcorn. Get all the kids a bag of microwave popcorn, and we have them mass it before it's popped and then after it's popped, and figure out how much water was released. So it's another, like, again, lab that students can do at home and in school at the same time, finding ways, to, collect information, not necessarily trying to be on the computer all the time. Sometimes we have to, but, trying to find ways to not always be on the computer.
And one of the things that your students might really get into is on your phone, there's so many apps available. So for example, my advanced chemistry students, I know they know how to figure out the gram formula mass. I'm not going to spend an entire lesson working on that. So I shared with them the gram formula mass app. So it speeds up what you're working with. They're not manipulating, going off the screen, trying to use a calculator in the bottom right. So that's a nice app in there. And then there's another one, which is a US Army US Army, I think, elements. And that one there does Lewis dots, naming ionic, naming covalent, empirical formulas, molecular formulas, percent, it brings it down. It's an app, it's faster. They can send me a screenshot of their score, gives me an idea. And all I ask is that you just list the chemical formula or the names as they go down on your screen. We set a timer. It's an excellent ticket. We set a timer and we'll say something such as, okay, in the next 10 minutes, let's see who gets the high score. It's a fun way. They print screen it, send it to me. I can see that we all participated. We learned something, on how to put different ions together, how to put different atoms together. And so, yeah, so there's so many free apps that are available. And since we are using the technology, those are also good ones that you can share with your students.
Annette, they want to know, what was the name of that first app, that gram formula mass app?
The gram formula mass app is, of course, on my computer, on my phone, it just says, it's a molar mass calculator. It's a molar mass calculator.
Yeah, my students actually also have an app that they like to use all the time. It's the periodic table app, quiz app. So like looking at their elements and symbols, things like that. Yeah. They all get a kick out of using that and then seeing how many they can get. And again, doing the same thing. And I'm sure everybody's aware of things like Kahoot and stuff. GimKit has a brand new program out for review that I've actually started using with my kids this week or last week, and they had a blast. It's a play on the game app Among Us, which is what all the kids are playing right now. So I was able to take a bunch of chem questions and put them in and have the kids practice like the important chem questions I wanted them to know for the unit we're in. And I was the most participation I think I've had the entire year. So definitely trying to find different ways to keep them engaged has been definitely the challenges I've been working on and starting to find things that are working. So that's great.
There's also another one called the camera colorimeter. And because when we were doing the electromagnetic spectrum, you can get the absorption of like lemonade. So we were making all these drinks. People had their Gatorade, and the colorimeter thing, you just put it over there and it tells you the absorption. So it's kind of cool. And that one's called so even all these apps that are being put out there, they're helpful.
Rory just said www.graphpad.com is another website to check out. Now, I don't know that one, so I'm going to write that down too.
Yeah.
I definitely agree. Talking with, I teach at a small school, so like Annette has a lot of chem teachers to talk to. I don't have anybody to talk to but myself. Definitely being able to reach out to other people has been a huge help. So definitely recommend. I know the Questar region is doing meetings with teachers in Questar. I'm sure other BOCES are as well. So definitely reach out to others for help and for suggestions and things like that. It definitely does make a big difference.
Thank you, Regina. Can you talk about that, about Flash ending on December 31st? Did that disable most of the PhET programs?
They're in the process of switching them over, so hopefully no.
That's what I thought. Yeah. Okay.
And I honestly, I don't know how to save stuff but I just know it's out there, and somebody was talking about saving one of her favorite animations. So I just wanted to have people be aware, if you have a favorite, try and save it.
I found a lot. If you guys go back to the summer, when you go back to the Master Teachers Summer Gallery, there are a lot of resources in there too. So, you know, for us to use. Yeah. There's also a
On that,
Sukemdu.
yeah, Kelly is asking for interactive lab websites and apps. I would definitely say work with
PhET.
because there's a ton of labs already there, and you can take them and edit them and tweak them for whatever you want or need. So there's a lot of resources already there. That's the PhET website that Regina posted earlier. So if you go to phet.edu/colorado.edu there, that one will definitely, not only are the interactives there, but there's lesson plans and worksheets and activities for them all there for you to use. So definitely give you a place to start if you're looking for stuff. So definitely I would recommend starting there. I did use that a lot in the spring.
And the lesson plans and worksheets are in Word, Google Docs, and PDFs.
Yes, they're all in different formats.
You're welcome.
Are there any other questions? Well, this has been a wonderful session. Thank you, Stephanie, and thank you, Annette. I think that this is definitely a video that will be revisited after today. We will make it available on remoteed.org. I also would like to bring to your attention that we will be taking a 2-week break for the holidays, and we'll resume on January 6th, where we were talking about literacy. Again, thank you to our presenters and to the Master Teacher Program. I wish you a wonderful holiday season and good health, and I'll see you all in 2021.
Yes, thanks everybody. It was great having you all here. Great session. Thank you guys. And enjoy the holidays.
Happy holidays, everyone.
Thank you.
Bye, guys.
Bye-bye.
We forgot to take a picture.